So first of all, we're going to talk about y equals natural log of x. And we're going to look at the graph of it first so I can explain where the formula comes from. Anybody know what the graph of natural log of x looks like? So it's kind of like this. Okay. So if I were going to draw the derivative of the graph of natural log of x, so what's the slope of that red part? It's always positive. Okay. So what I draw has got to be above the x-axis. Okay. And it's really big at the beginning, really small at the end, so it looks kind of like that. Do you agree? Okay. So the formula for the derivative of natural log of x is 1 over x. Now, that's kind of interesting because if I actually draw 1 over x, I get that blue part, but I also get this part over here along with it. The blue and the green together make y equals 1 over x. Okay? So it's kind of strange that whenever we talk about the derivative of natural log of x, that you get 1 over x. Well, technically there's a restriction here that the derivative is only y equals 1 over x for y is greater than or equal to 0. Really greater than, not equal to. Because really we just care about the blue part of it. Because if the original graph is the red and I want the derivative, it's got to be the blue part, not this part over here. Now, that really doesn't affect the rule or how you use the rule. I'm just throwing it out there so that you understand where the graph and the equation comes from. Okay. So let's say you have y equals 5 natural log of x. So 5 is just a constant. It's just a number in front. So if I just find the derivative of that, I do the derivative of a natural log of x, which is 1 over x, and then times it by the 5, so you get 5 over x. Questions about that one? So what if instead you have y equals natural log of 5x? So 5x is like it's in parentheses there. Now if they didn't put the parentheses, it would mean the same thing. I'm just telling you that just so you know. So when we do these rules that we're going to talk about with natural log, product rule, quotient rule, chain rule, all of those rules still apply. Okay? So you know when you have like sine of 4x and you have to multiply by 4 after you take the derivative? Same thing sort of happens with natural log. When you have natural log of something, you do the derivative of natural log, but then you have to go back and think about the chain rule. Okay? So the derivative of natural log of 5x is 1 over 5x, and then you multiply by the derivative of 5x, which is 5. And it does reduce, and notice that those two things are the same, or close to the same. The 1 over x part is the same. It still has a 5 on the first one, but the reason that it comes out to be like that, because in my mind, there should be a 5 here somewhere, okay? But the reason it comes out to be like that has to do with the properties of natural logs. Your book does a lot with the properties. We're not going to talk about the properties unless at some point we need them. But one of the properties says if you have two things multiplied in a natural log, that you can change it to adding. So I could change that to natural log of 5 plus natural log of x. And then when I do the derivative, natural log of 5, the derivative is 0 because that's a number, and so that's why I end up with that. The properties were a big deal probably in pre-calc. You probably sort of remember that there were properties, but most of these you can do without having to do with the properties. Okay. All right, let's look at another one. Okay. Similar type of problem. So I put the x squared minus 5 on the bottom because it's 1 over that. And usually instead of putting 1 over, I usually just find the derivative and put it on top because I know that's what's going to happen when you multiply. So the derivative of x squared minus 5 is 2x. Nothing really to do after that. That's the answer. Okay. y equals x natural log of 3x plus 4. Alright, so this one is one where you're going to have to use the product rule along with this new rule that we're talking about for natural log, because there's an x and also the natural log of this. So there's two functions. Okay? So we're going to start off with the first, which is x, times the derivative of the second. Okay, the derivative of the second one, that's natural log of something, so 3x plus 4 is on the bottom. Multiply by the derivative of the 3x plus 4, so 3 is on the top. So this was first times derivative of the second, plus the second, which is the natural log, times the derivative of the first. The only thing you could do if you wanted to simplify that a little bit is multiply that x, so you can make it 3x over 3x plus 4 plus natural log of 3x plus 4. You cannot cancel the 3x's because you still have that plus 4 on the bottom. Alright, so here we go. The fifth one, we have y equals natural log of x to the 10th. So the last one you had to do the product rule because it was like two functions multiplied together. Okay? So this one is not the product rule, there's not two functions, but there's a power, so we've got to use the chain rule. Alright, so if I use the chain rule, 10 comes down in front, subtract 1 on the power, and then you multiply by the derivative of the natural log of x, which is 1 over x. Nothing really you could do. You could, if you wanted, to make that 10 over x and then natural log of x to the 9th. Alright, so number 6. This one also has a power in it, but it's different than the last one. Can you tell me what's different about the power? You notice how on the last problem the 10 was like the power of the whole thing? Natural log was inside. That power is only part of like the natural log part. So this ln is natural log of this thing to a power. So it's not, I don't start with the chain rule because that's not like the over, it's not over at all like it was on the last one. Okay, so I start with, okay, what's the derivative of natural log of something to a power? Well, it's 1 over the thing that it's natural log of. But then I have to multiply by the derivative of the power, and that's what's going to go on top. Okay, so the derivative of the power, that's where I use the chain rule. So it would be 4 times 2x plus x squared to the third power, and then I multiply by the derivative of the inside, which comes out to be 2 plus 2x. Questions? Now, I do want you to simplify here because there are things that can go away. There are 3 of these, and I can get rid of 3 of those. So I would have 4 times 2 plus 2x. You could. Over 2x plus x squared. Yeah, you can multiply the top if you wanted, or you can just leave it. Okay, so number 7, we have natural log of x over x minus 3. I would say that this one and maybe the next one are the hardest two when you're looking at natural logs, and it's because the derivative of the inside on this one has to do with the quotient rule, and the derivative on the next one, it'll be the product rule. And it just makes it look more complicated, and it's kind of different. So I would say that 7 and 8, if there are hard ones here, they're probably the hardest. You start off with the derivative of the natural log of the thing. Okay, so let's think about it. It would be 1 over whatever's in parentheses. Well, 1 over a fraction is the same as flipping the fraction. So it's the same as x minus 3 over x. If I do 1 over x minus 3, that's the same as this. And I would prefer you to write it this way just because I think it makes more sense and it's more understandable. That over there just looks difficult, okay? But then you have to do the derivative of the inside. I will tell you that in the past, students have trouble with the derivative on the inside because they always go back to this. But that's not the inside. Okay, that up there is the inside, so I have to do the quotient rule of that. Just be careful about that. Make sure you understand where we're coming from. So we're going to do the quotient rule on the inside. We have bottom times derivative of the top, which is 1, minus the top times derivative of the bottom, which is 1, over the bottom squared. Okay?
Why don't you flip the first part?
That's fine. Alright, so let's finish the top there. X minus 3 squared is on the bottom. I do need to simplify this part right here. I think we end up with a negative 3. Okay. And there's one thing that can be canceled or simplified. Yeah, we have that. By the way that you flip it and everything, you have this x minus 3 here that will go away. So we end up with negative 3 over x times x minus 3. So similar kind of problem as the last one, but instead of a quotient inside, we have a product. So we have to use the product rule when we do the derivative of the inside. Okay. So when we do the derivative here, you would have 1 over that thing. And then we want to multiply by the derivative of the inside. So the derivative of the inside is where we take the product rule and multiply it out. So we have first times the derivative of the second. Okay, the derivative of square root of something is 1/2 2x minus 1 to the negative 1/2 times the derivative of the inside, which is 2, plus the second. I'm running out of room here. Times the derivative of the first, which is 3. Alright, I know this is yucky looking. There's not going to be a lot of things that you can do with it, but we'll go ahead and work it out. So if I multiply this part right here out, really I just get 3x and then this part here, because 1/2 times 2 is 1. So I get 3x times 2x minus 1 to the negative 1/2. And then the next part, there's nothing really to do, so I just get that. And then at that point, you just leave it. There's not a lot to simplify. Usually there is with product rule, quotient rule like on the last one, but with product rule, it's usually not very nice looking. 9. This one just looks strange because there's 2 natural logs in the problem. Okay, so this is natural log of 5x plus 3. So this is the inside of the first part. Okay, so the derivative of the whole natural log of the natural log is 1 over 5x minus 3. No, sorry, ln of 5x minus 3. Okay? Then I want to find the derivative of the inside. So forget about the first natural log. Now I'm dealing with the inside, which is in parentheses. So the derivative of natural log of 5x minus 3 is 1 over 5x minus 3. Then I have to find the derivative of the 5x minus 3. It's like I'm doing the chain rule twice, which is 5, so I multiply by 5. Nothing really you can do there to simplify other than if you just want to put the 5 on top and put it all together just to make it one fraction, you can do that. Okay, so this is a combination of basically a power, a quotient rule, a rule about natural laws. It's got a little bit of everything. There's a couple things that you can do. I personally think that this is a problem where it is easier to take that power and put in front, just so you don't have to deal with the power. What is the power here? Yeah, so I would personally rewrite that as 1/2 natural log of x minus 3 over 2x. After you do that, then you don't have to worry about that 1/2. You just know that 1/2 is in your answer. Okay? And then you just have the product rule or the quotient rule to deal with when in the middle of the natural log. I think it's easier to put the 1/2 there. If you don't think it's easier to do that, you can use the chain rule and then flip it and do some things. It's going to be harder to get to the simplified answer. Okay? So that 1/2 power, that's just a rule about natural logs that you can do anytime that you have a power, is you can put that power in the front of the natural log. So really I didn't do anything with the derivative. I just put the 1/2 in front because it's a rule of natural logs. Okay? So now, when I do the derivative, the 1/2 is just there. Okay? I want to take the derivative of natural log of the inside, so that is 1 over what's inside, which is the flipping thing. And then we multiply by the derivative of the inside. Remember to go back to what the problem originally said when I do the derivative of the inside. So we have the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 2, over the bottom squared. All right, we need to work out that top on the inside there. So we have 2x minus 2x plus 6. On some of your tests, I noticed that you guys forgot, like when you multiplied this and you have this negative, but there's also another negative. Some of you forgot that. Just reminding you there. And then on the bottom there, if I square that out, would be 4x squared. Alright, so if I simplify a little bit more, the 2's will go away. One of the x's will go away. And the 6 and 4 you can reduce. And so that's the simplified answer that you would get.